Here I have CH4 and 2O2, okay? I need to make a prediction about what this will yield. I'm going to have some chemicals over here, okay? And I actually know what those are going to be. I'll go ahead and tell you what those are. It's going to be some number of CO2, right? And it's going to give me some number of H2O, right? That's still on the board. I know that that's with the glare, it's kind of hard to see. It's visible. So we'll take a look. So what happens in chemistry? And this is what's fascinating. What really happens in chemistry is when you want a reaction to happen, if I were going to use methane as the gas in my gas grill, what happens is you take the methane and you put it into a container. In this case, you put it into the gas grill. It comes out the gas ports on the grill, and there it is. It goes into the grill. And there's also oxygen in the grill. There's oxygen in the air. We'll probably have a nearly infinite amount of oxygen in reality. But when we're balancing these, we're just going to talk about the ones that are not in excess. So we'll take our oxygens, we'll put them in the grill, right? And what happens is you take the striker on the grill and you hit those molecules. You smack them, you excite them. And we know from an earlier unit, that heat, or the temperature rather, of a sample is the motion of the particles. How fast are those particles moving? Well, the particles move so fast that they come apart. They detach from each other, or at least they move away from each other far enough that they detach. So this methane that had carbon at the center of it, it doesn't have those hydrogens attached to it anymore. They're far enough apart that oxygens can work their way in and they can attack that carbon. That will give me a carbon dioxide. And at the same time, each of these oxygen atoms will be attacked, or they will attack two hydrogens. They will be attacked by two hydrogens, sort of depends on the way you look at it, in order to satisfy their octet rules, right? And what we get as a result are our products. What happens in chemistry is that the atoms, when you heat them, they spread apart. And if they're going to react, if their octets are better satisfied by arranging themselves in a new way, that's what's going to happen. That is the rules of chemistry. Okay, that's what happens. And that's me smacking the bag against the wall. That's exactly what you're doing when you heat a sample. When you heat a sample, you're literally shaking it. That's literally what that is. You're making those atoms move apart. You're adding kinetic energy to the sample. That's what raising temperature is. We go back to our kinetic theory of matter. We talked about that. When you heat a sample, when it goes from a liquid until a gas, the particles spread apart. When they spread apart far enough, other particles can attach in new ways. And that's what we have here. And so CH4 and 2O2 will yield us a single CO2. And when we balance these, we would never write the number 1 here. We would just leave it blank. But for this demonstration, we'll write our number here. And it gives me 2 H2Os. Okay, that's the chemistry of combustion of methane. The sample we started with, the CH4, that's methane. Okay. Now there's another equation I want to talk to you guys about, and it is the creation of sodium chloride. So I start out with 2 NAs and some number of, well, you're going to know what I start with, and a Cl2, chlorine gas. Okay, elemental chlorine. We call it elemental because it's pure. It exists with just chlorine in the molecule. I'm actually going to let me erase this down here. It's going to get in our way. I'm going to get this reaction out of the way. This one's actually simpler. It's simpler. But this is what we start with. I start with a couple of sodiums, and a bonded molecule of chlorine gas. I don't know if you can see, I've written on these chlorine, right? Sodium. Should have maybe demonstrated that with the other reaction. But this is going to yield, it's going to give me a result. So what do? I take my chlorine gas, I take my sodium atoms, I put them into my mixing jar, right? Shake them around. While they're in there, the chlorine is able to separate from its buddy, from its other chlorine. The sodium is going to liquefy, and it's eventually going to turn into a gas. And as gases, they're able to rearrange themselves. And very quickly, sodium gives up its electron to something, maybe to this chlorine. The chlorine will gain an electron. When they do that, they become magnetically attached. And we have sodium chloride. I have another free chlorine here. I have another free sodium here. They receives an electron, loses an electron. They suddenly become magnetic. They stick together. We have this ionic bond, 2 sodium chlorides. And so my product of this reaction is going to be 2 NaCl. And I probably wrote that too high on the board to be visible in the video, but we can see our reaction. 2 Na plus Cl2 yields 2 NaCl. That's chemistry. That's all of it. That is exactly how this stuff happens. And we needed to learn about the kinetic theory of matter. We needed to know that speeding up these molecules, speeding up these atoms, getting them to get just enough space between them so that other atoms can come in there and attach, that heat that causes the reaction, that's vital to understand how this is going to work. Okay. All right. That's my quick Lego demonstration of. Sorry, I'm trying to figure out how to stop recording. Oh, that's my quick Lego demonstration of chemistry.